Greetings, my name is John Gabriel, and this is the New Calculus channel. Welcome. In part 16, I talked about geometric measure, and what I'd like to do now is share with you something that I haven't actually shared with the public before, and it's something that would have originally been part of my book had it been published. What you had to know in mathematics, but your educators could not tell you. So let me begin now by showing you how all arithmetic operations were actually first defined geometrically, and that's not just the four basic ones, but everything: exponentiation, roots, everything else could be found geometrically. So let's begin. Now, as you see in the previous episode here, I showed you this diagram here, and I explained to you that these lines are in proportion because of the similar triangles, and all this theory was developed by the ancient Greeks without using any numbers, only magnitudes, and the Pythagorean theorem. Okay? So what I'm going to show you now is how this actually works, the actual mechanics. Okay, so I showed you here the four basic operations, and now I'm going to give you some examples so that you can see what's happening. And before you actually continue watching, you may want to watch how to construct a circle given 3 points that lie on the circle. So this is something that's vitally important because you use a circle to perform the operations of multiplication and division. Okay, in fact, division comes before multiplication because multiplication is a form of division. So watch this little applet here. There are many, but the URL for this one is Math is Fun, and it shows you how to construct it. And I'm going to show you now how this works in a very clever way, and this has never been revealed to anyone before. It's new knowledge that you will not find anywhere. As I said, it has not been realized. It's not even in the elements, although this idea to construct a circle through 3 points is done using the knowledge from the elements. All right, so let me show you very quickly. So what do we need to do to be able to find the product of two magnitudes? Now remember, we do not have numbers, okay? So what we could do is we could choose our magnitudes, and it doesn't matter how we choose them, all right? I'm going to keep them as whole integers, but they don't have to be. They can be even magnitudes representing pi or square root e or any other magnitude. But I'm going to basically keep them this way so that you can see what's happening, okay? So now, the first thing you do is you choose a magnitude. Let's say a length, the dark blue line and the light blue line, as you see over here. And then choose a unit, right? And so you can choose any unit you like. I mean, it doesn't matter what length you choose. We could choose one, we could choose this length, any length you like in particular, all right? So I'm going to choose that length there. Then the next thing you do is you draw a circle around the 3 points, these three green points here. And the product of this light blue line and the dark blue line will be this distance here, okay? This is the product, this red line. Okay, so 3 times 4 is 12, isn't it? Now remember, my unit is 3, and 12 divided by 3 is 4. So this is the product. Of course, if I had it like that, then you'll see that this distance here is 12, okay? So I'm simply choosing a different unit, like so, in order to show you that we can perform multiplication simply by using the circle. And in fact, that's where all the operations of arithmetic come from. And so what about exponentiation? Well, exponentiation is simply doing the same thing, right? So if we had 3 times 3, like so, And let's make this the unit 1. 3 times 3 is 9, right? So we could just simply, once we have 9, we find 3 times 3 is 9, and we want to multiply by 3 again. Well, we know this is the length that we need to multiply the 3 by again, and we could expand this to 9, right? And of course, this length down here, 27, is the exponentiation. Okay? Now, this is an ingenious method, and of course, the division is also obvious, but it would be done slightly differently. You would choose the magnitudes and the unit, and then you would draw a perpendicular. You would extend the perpendicular till it cuts the circle here, and I'm sorry, let me repeat that. You would choose this magnitude and this perpendicular here, okay? And then 9 divided by 3 would be 3, right? Or 9 divided by 3 would be 3. So it doesn't really matter how you do it. If you had 6 divided by 2 is 3, and 6 divided by 3 is 2. So all in all, you can use geometry to perform all the arithmetic operations without even knowing what numbers are. Now remember, we choose the unit, and we want to talk about these magnitudes in algebra without looking at the circle in geometry. And that's why we use numbers. Once we pick our abstract unit, then we can talk about these lengths without actually looking at the diagram. And that is precisely what leads us to the definition of a number. A number is the measure of a magnitude, because now in multiplication, both of these lines here measure this line individually. So we could, if we used 3, it would fit exactly into this line too. And similarly, we could measure the red line with this blue line here. It would fit in 3 times. 1, 2, 3, right? So if you look at my book on an introduction to the single variable new calculus, you will see I've added a new section and explaining all these details. So arithmetic is actually measure, okay? It's measure. That's what it is. We're doing measures. And so I've added this section in here to show you what exactly you are doing when you're multiplying and dividing. And so you can go to chapter 5, which is how we got numbers, and this section here will explain all these details to you. In fact, what I've done is I've covered this in a previous video, and I had it in a PowerPoint, but it wasn't part of my book. So now I've added it to the book, and of course you can access this book online by going to my main site, and I will also provide a link to it. The book is called An Introduction to the Single Variable New Calculus. It is, without any shadow of doubt, the most important mathematics book ever written, okay? And you will find none of the information therein published anywhere else or discussed anywhere else, because it is knowledge that I first discovered. Okay, so nobody before me discovered this knowledge, and it is based on the foundations of mathematics, which are the elements of Euclid. So I hope you've enjoyed this little presentation, and that you will study what I'm telling you, because it will help you to understand mathematics better. And I'll finish this video off by saying that a number describes the measure of a magnitude, okay? And we can use different measures, as I've shown you here. The first and most primitive is the difference operator, then the sum operator, then the quotient or division, and then finally the product or multiplication operator. And they all are defined in terms of difference. Very well then, this is the New Calculus channel. My name is John Gabriel. Until next time, goodbye.